All right, this is Dr. L again. I'm going to show you how we use the spectrophotometer in our lab here to measure colored ONP product for the lactase lab. So here is a set of reaction tubes from this lab and that a student did earlier. Each row is one of the experiments. So this back one is the experiment at pH 5. And this front one is the experiment at pH 8. These two tubes are the blank tubes. They contain only buffer. These three, 1, 2, and 3, each of them is a set of 3 replicates of the same thing containing buffer plus ONPG, which is the substrate. So these are the no enzyme control groups. And then these are the actual experimental groups. So we've got buffer plus substrate OMPG plus lactase enzyme at 2 different pH, pH 5, pH 8. So, I can actually look at them and immediately see that if you add enzyme, you get product. And if you don't have enzyme, you don't get product because the product is yellow. And I can also immediately look at this and say, well, looks to me like there's a lot more product in the pH 5 than in the pH 8. But in science, we need to actually prove that, and we need some data to demonstrate that and to analyze. So the way we get data is we measure absorbance in a spec for this lab, a spectrophotometer. This is a typical spectrophotometer, and it is set at 420 nanometers. And the larger number across the top is going to be where the absorbance numbers are. Yellow products absorb light at 420 nanometers, so the spec is set at 420 nanometers. If we were measuring something else that was a different color, we'd change that wavelength setting. The first thing that you want to do when you use a spec is turn it on and let it warm up. And then once it's warmed up and it looks like it's ready to go, which this one is, you blank it. So you take your blank buffer only tube and you make sure that you orient it so that the clear, not the frosted, but the clear ones are going to, I'm just going to set that down for a minute actually. I'm going to open the spec and then I'm going to put this in so that the clear, I can see through it, right? Those are the clear sides, not the frosted sides. And it's going to go into this little cuvette holder and I'm going to press that down firmly. And there's a little gap down here and over here, and that's where light comes through. So the light's going to come through this sample, right, in that where it is in the machine. I close the lid and I tell it to blank by hitting the measure blank button. And it's setting the blank, it's telling it there's nothing in here, right? This is 0, and that 0 value I would write down as my first data point, the data point for the blank. And also to prove to myself in my notebook that I actually analyzed the sample, right? That I'm using the spec correctly. So from there, you just go on and measure whatever you want to measure. So if I was measuring control, I had just finished making the control tubes, and they had just finished going through 2 minutes of timing and were now ready to be measured in the spec, then I would pop them in. Here's a control tube, an example. I'll pop it into the spec, and then I'll just look over here, and it's telling me the absorbance is 0.005, right? So just a trace amount of absorbent. That's my data point. I write that down. Not very much, essentially 0. This is a very clear fluid, right? And you finish measuring each set, one at a time. When you get to measuring the actual samples that had lactase in them, plus substrate, plus buffer, they're yellow in color, right? And you're gonna see some real absorbance there. So we pop that in, close the lid, and look at that absorbance number, 1.193. Now, if in the actual experiment, these samples have been sitting for a while, so that's a fairly stable number. But when we do this just 2 minutes after mixing the reactions, the number will keep going up because the reaction's happening as you watch it. So you just make sure that you time for 2 minutes, put it in the spec, write the number down, and that's your data point. We'll take another look. If you have a lot of product, right, which might be the case with this very orange sample, you might actually see a number like this, and that's no number at all. What it's telling me is there's so much yellow product in there that it's beyond the quantification range for this particular instrument. So in order to know what that absorbance is, I would have to dilute the sample. So I would take this sample back out, get myself a new tube, and pretty quickly make a dilution of that. For example, I might mix 600 microliters of buffer plus 200 microliters right from this tube, mix it, measure it. I would get, that might bring it down to being within the quantification limit, and then I would write that number down, and then I would multiply it by the dilution factor to be able to then analyze that. So that's the basics on how to use these spectrophotometers. When we're done with them at the end of the day, we turn them off. There's a power switch at the back. And that's it.